Okay, the mole and avogadros number lab. Um, First thing we need to go over is that um, a mole can be confusing because um, it's this big number, 6.02 times 10 to the 23rd. Students see scientific notation here and they kind of get intimidated. But what 6.02 times 10 to the 23rd is, it's just a number, a shorthand or a slang that scientists use to say this really big number, 6 times 10 to the 23rd. Kind of like we say a dozen, meaning 12, or we say a century, meaning 100. Um, so an Avogadro's number, that's just shorthand. Okay. The next thing you need to know is that to get the mass of one mole of anything, we look at the periodic table. So if you look at the periodic table, um, and you want to know the mass of one mole of anything, let's look up the periodic table. And okay, so that one doesn't have weights. Here we go. Here's one. A mole of nickel would be 58.69 grams per mole. A mole of boron would be 10.8 grams per mole. Carbon is 12 grams per mole. Now I'm rounding those numbers, but here's how we write grams per mole. And why do we have to write it like this fraction? Well, we actually can write it like this too. Um, not not with a slash, but like a fraction, like you would do in math, or with uh, stoichiometry. So excuse me, it must be nap time for me. I'm yawning. Okay, so this practice problem right here. When we are given a problem, they give us one amount. So we start with 1 gram. We can use this information to calculate how many H2O molecules there are in 1 gram of water. Well, holy cow, that's a big problem. I'm intimidated by this. What do? We start with the basic information they give us. So we know 1 gram of 1 gram of water, H2O. We also know our chemical formula is H2O. So we can go and calculate the mass of 1 mole of water by adding oxygen, which is 16. I'm rounding that up to 16. So that's O, and we need 2 H's. So I'm rounding that to 1. So 16 plus 2 is 18. And you see that right here. They didn't round it. They carried all the decimals. So immediately we have 2 bits of information. And why was it necessary for us to retain that grams per mole? Well, we need to know 1 mole. The mole is our bridge to get from grams and molecules and, well, moles. But because we have this grams per mole relationship, moles become our bridge. A bridge to go from one unit to the next. So here you can see we have grams on the top, and in our equation we want to have grams in the bottom. Why? Because just like if you were to have the fraction 2 over 2, and the 2's, they cancel each other out to get 1. So 2 over 2 is equal to 1. You reduce that just like in basic algebra. Well, here you have grams of H2O over grams of H2O. Now, no, they're not in the same fraction together. One is in this numerator and one is over here in this denominator, but they can still cancel each other out. The 1 stays, the 18 stays, but that unit, grams of H2O, that cancels. So that would leave us with this 1 mole of H2O. We don't want moles of H2O, we want molecules, but here's how moles act as that bridge. Because we know the mass of a mole, and we know that number that moles, it's just slang for telling us 6 times 10 to the 23rd. We can use that 1 mole of H2O. We know always that 1 mole of anything, 1 mole of water, would be 6.02 times 10 to the 23rd molecules, or particles, or oranges, or whatever you're working with. Here we're working with water molecules. So our mole right here would cancel out with this mole right here. So this unit's crossed off, this unit's crossed off, this unit's crossed off, this unit is crossed off, and we're left with molecules. All of our numbers stayed. So we would do 1 times 6.02 times 10 to the 23rd, divide that by 18.0152 grams, divided by 1, and that's how you get this number right here. So, in order to do this, how many grams of H2O are necessary to weigh out 1 mole of H2O? Okay, well, I am going to do a similar problem for you. So I want to go to my applications. I want to go to Microsoft Word. Sorry for not having this open. I'm going to go to Excel. I'm also showing you the cheater's way of doing all the math. So how many grams of H2O are necessary to weigh out 1 mole of H2O? Well, I'm going to do 5 moles of H2O. Okay, so let me do this. I want to show my inside borders. Okay, so what goes underneath that, not H2, oops, oh, okay. What goes underneath this 5? Well, nothing goes underneath this 5. Occasionally, in more complex problems, you might get something in the denominator. I might tell you a certain number of miles per hour in physics, and then you would have miles on top and hours on the bottom, but you don't here. So I usually just put a happy face in to remind myself that there's nothing there, that it's okay for that to be blank. So we have 5 moles of H2O, and what do we want to get to? We want to get grams. Well, what relationship did we know? We knew this relationship right here, that grams per mole that we get from the periodic table. So we already have water calculated, so we can just use that number that we have. Now, what did we say? It was, we want, if we have moles on top here, we want moles on the bottom. So I know that 1 mole of H2O weighs about 18 grams. Okay, am I done now? Was that the problem that I wanted? Let's go check. How many grams of H2O are necessary to weigh out 1 mole of H2O? So, yeah, I'm done. So all I have to do is, to get my answer, I would do this problem times that one, oops, equals this times this divided by that. Okay, and what's wrong with my value? Star? Why is that not working? Okay, well, anyway, 5 times 18 divided by 1 is whatever 5 times 18 is. Okay, so let's move on to the next problem. How many molecules of water are in 1 mole of H2O? Well, so I'm not doing the problem for you. I'm going to continue on with my 5 moles. So I'm at, we want to know how many molecules are in 5 moles. Well, I know that 1 mole, which was already there, of H2O is actually 6 times 10 to the, where's my caret? to the 23rd molecules. Okay, so that's how you do that one. Of course, you need to change the 5 to a 1 and do the math. Okay, I wanted to do the next one. How many moles of H2O are there in 1 gram of water? So we, again, would start with, if I give you 5 grams of water, and I want to go to grams, or I'm sorry, I want to go to moles, right? Was that number 3? Yeah. Okay, so I know, what do I know about grams and moles? I know that 1 mole of water is 18 grams. I have grams on the top here, so I want grams on the bottom. Why? So we have 1 on top, 1 on the bottom, they cancel out, and we can get rid of that unit and move on to the next one. So I know that that was 18 grams of H2O is 1 mole. And why am I always writing out this H2O? Well, in some problems in the future, you might convert from water to oxygen, or water to hydrogen, or water to some other element or compound. So it's important that you specify what grams or what number of moles you're dealing with. So I should be putting 1 mole of H2O here. And that is not chemically correct because my H's are lowercase, but that is how you do that one. Let's see, how many molecules of H2O are in 1 gram? So 1 gram of water. Okay, so we're going to start with our 5 grams of water. We know that 18 grams is 1 mole. Okay, I don't want moles though, I want molecules, but I know that 1 mole of H2O is 6 times 10 to the 23rd molecules. So you would just have to do the math out. 5 times 1 times 6 times 10 to the 23rd divided by 18. That's how you do that problem. Okay, so you do your measurement. If you cannot get the requested diameter, 3 centimeters. Try a couple of times. If you still can't get it, just let me know and use the number that, use the size that you got. Now, here, this is a little different. We're doing drops, tablespoons, and milliliters. So we know that there are 360 drops in 1 tablespoon, and there are 14.8 milliliters in 1 tablespoon. So I'm just going to write myself a little key here. What was that? That was, let's scroll so this is easy for me to see when I have 2 things open. I know that there are 360 drops and 1 tablespoon. And I also know, put an equal sign in there. Oops, nope, it's not equal. I also know that there are 14.8 milliliters and 1 tablespoon. Okay, so calculate the number of drops in 1 milliliter. So I'm going to start with the information they give me, 1 milliliter. And let's get rid of all this stuff. Okay, I want to go to drops. So if I know milliliters, and I have all this information here, what path can I use to get from milliliters to drops? Well, this drops right here is attached to tablespoons. That doesn't really help me. But what does help me is if I use tablespoons, similar to I used moles earlier, I can use this tablespoon and this tablespoon to get from milliliters to drops. So here what I do. I would do milliliters to tablespoons and tablespoons to tablespoons and then to drops. So what the heck is Mrs. Taylor talking about? Well, I'm going to start, because I have milliliters here in this numerator. I need to fill in my denominator over here next. So I'm going to do my 14.8 milliliters, and that was attached to 1 tablespoon. Okay, now my milliliters would cancel. So I have 1 tablespoon, and I want to get to drops, so I can use this equality where I know that 1 tablespoon is 360 drops. So that's how you would do that one. Calculate the surface area of a circle. So of the circle that you measured. So pi times d, so 3, 4, 5 centimeter, whatever your diameter was, squared over 4. Then you use that information, your surface area you put in here. Just do the math and you come out with the number of molecules in the top layer. Okay, and when we want to calculate the concentration in grams per milliliter, that's all done for you. So all you have to do is the math there. And this one, you convert the number of drops to create the monolayer to milliliters, da 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 da. Okay, if you know the number of moles, you calculated the number of drops in 1 milliliter already up here. You did that. So you take all that information that you already have calculated, plug it in here, and then you come up with this answer. The post lab, explain why you may have a slightly different number. Well, if you have a slightly different number than me, what if our measurements were different? They are. They will be different for everyone. And then this one right here, calculate the number of moles in that many grams of NaCl. So you will need to go to your periodic table. You will need to calculate the mass of NaCl. So 23 plus 35.4, and that tells you your number of grams per mole. And then if you know your grams per mole, and you know, where did my thing go? And you know how many grams you have. If you go from grams to grams per mole, then you're good to go. So what you're given some number of grams of NaCl, and you know how many grams. So your 35 plus, what was Na? Na was 23 plus 23 grams of NaCl is 1 gram. Oops, I'm sorry, is 1 mole. Okay, so all you have to do is plug in the appropriate numbers, do the math, and you're good to go. If you have any questions, just let me know. Send me an email. Thanks. Bye.